Copper chelating assay was determined by copper chelate titration using pyrocatechol violet as metal chelating indicator. The complex of pyrocatechol violet and copper absorbs at 626 nanometers. Thus, copper chelating activity is proportional to the decrease in absorbance at that wavelength. For copper chelating activity, the material needed is samples dissolved in water. Reaction tubes. Sodium acetate buffer 50 millimolar and pH 6.0. Copper sulfate 0.1 mg per milliliter in sodium acetate buffer. And pyrocatechol violet 0.3 millimolar, also in sodium acetate buffer. Prepare pyrocatechol violet 0.3 millimolar by adding 5.8 mg to 50 milliliter of sodium acetate buffer. Next, prepare copper sulfate 0.1 mg per milliliter by adding 100 mg to 100 milliliter of sodium acetate buffer. First, measure 1 milliliter of sample or water for blank to a reaction tube. The samples must be tested in various concentration and in triplicates. Add 1 milliliter of copper sulfate solution and homogenize in the vortex. Add 250 microliter of pyrocatechol violet solution. Homogenize in the vortex again. Read the samples at 626 nanometers in a spectrophotometer. The chelation percentage is given for mathematical expression shown in the slide. Metal chelating assay was based on the measurement of the absorbance of iron 2+ ferrozine complex after treatment of a ferrous ion solution. Ferrozine forms a complex with free iron 2+, but not with iron bound to other chelators. Thus, a decrease in the amount of ferrozine iron complex formed after treatment indicates the presence of antioxidant chelators. The ferrozine iron complex produced a red chromophore, with absorbance that can be measured at 562 nanometers. For iron chelating activity, the material needed is samples dissolved in water, reaction tubes. Ferrozine solution 5 millimolar, iron chloride solution 2 millimolar, and deionized water. Start by measure 1 milliliter of sample or water for blank to reaction tubes. The samples must be tested in various concentration and in triplicates. To the samples add 3.7 milliliters of water and 100 microliters of iron chloride. Mix in the vortex. Add to the mixture 200 microliters of ferrozine, and homogenize in the vortex. Next, incubate 10 minutes at room temperature. Read the samples at 562 nanometers in a spectrophotometer. The chelation percentage is given for mathematical expression shown in the slide.
Seafood age. Smart food choices, no matter how old you are.